Alright, so we have the following circuit. We have to find V1 and V2. So let's write directions of current. Let's call this I1. Let's call this I2. This is the ground node, so it'll be 0 volts. And let's call this I3. So let's write the node equation for V1. So it's 3 amps. And it will be equal to I1 plus I2. Then we have node V2. And it's I1 plus I2. And this will be equal to I3. Okay, now let's write the equations for I values. So it's V1 minus V2 all over 4,000, because 4 kilo ohms is 4,000 ohms. Oh, wait, sorry. This is not supposed to be 3 milliamps. It's supposed to be 0.003 because it's milliamps. So if you want to convert milliamps to amps, you divide it by 1,000. So now we have I2. I2 is going to be a little tricky, so we'll get back to that later. I3, it's equal to V2 all over 1,000 ohms. 1 kilo ohm is 1,000 ohms. Now let's focus on V2. Sorry, I2. So let's see. Alright, so let's call this VA. So V1 minus VA all over 2,000 ohms. Well, technically it would be I2, but what will VA be? Well, if our current keeps traveling in this direction, we see VA will increase by 3 VO, and then it'll equal to V2 as it leaves from the positive terminal of this dependent voltage source. So VA plus 3 VO is equal to V2. And if you rearrange for VA, it's V2 minus 3 VO. So now we can plug it in. This becomes V1 minus V2 minus 3 VO all over 2,000. But now let's find a way to get rid of this VO. Okay, well, we actually see VO is going to be equal to V2 because since this is the ground node, it's going to be 0 volts. So V2 minus VO has to equal 0. And so if V2 minus VO is equal to 0, then that means V2 has to be equal to VO. So VO will be V2. Now it's V2 minus 3 V2. So that's minus 2 V2. And then minus minus, that turns into a positive. There we go. Now we have everything we need to start solving. So let's take this one, 0.003. Okay, hold on. Okay. This is equal to V1 minus V2 all over 4,000 plus V1 plus 2 V2 all over 2,000. And now you have this one. It's equal to V1 minus V2 all over 4,000 plus V1 plus 2 V2 all over 2,000. And this will be equal to I3, V2 over 1,000. Now let's bring this over here. Let's try and break everything down more. Alright, so V1 over 4,000 plus V1 over 2,000. Let's see what that gives me. That gives me 0.00075 V1. Now we have V2 over 4,000 minus V2 over 4,000 plus 2 V2 over 2,000. So let me see what that gives me. That gives me 0.00075 V2 as well. Alright, now that's our first one done. Now let's focus on the second one. So V1 over 4,000 plus V1 over 2,000. We already know what that was because we just solved it. 0.00075 0.075 V1. Now we have V2 over 4000 plus 2 V2 over 2000. That's also 0.00075. But then we have this one. So let's bring it to the other side. So it will be 0.00075 V1 minus V2 over 1000. So it'll be 1 divided by 1000. So it's pretty much 0.0. Hold on, let me write it here. It's pretty much hold on, 0.00075 V2 minus 1 over 1000 V2, 1 over 1000, that's 0.001. Now 0.00075 minus 0.001, that gives me 0.00025 V2. Okay, so let me just quickly double check everything. Oh wait, hold on, let me double check again. 0.00075 V2 minus 1 over 1000 V2. 1 over 1000, that's 0.001. So 0.00075 minus that. Okay, sorry, it's minus 0.00025 V2. Okay, my apologies. And this is equal to 0. Now let's bring this to the other side. So 0.00075 V1 equals 0.00025 V2. Let's isolate for V1. So divide both sides by 0.0. Actually, let's isolate for V2. Okay. So 0.00025 divided by 0.00025. This and this cancels out. So now we have 0.00075 divided by 0.00025. And that gives me 3V1 equals V2. Now let's plug that into here. So since V2 is 3V1, I'll put that here, 3V1. And now we can solve for V1. So this one, it will be 0.003 equals 0.00075 V1 plus 0.00075 times 3V1. That gives me 0.003 V1. This and this cancels out, so V1 is equal to 1 volt. And now we can see what V2 is equal to. V2 is equal to 3 volts. And yep, those are our final answers. So it's 1 volt and 3 volts.